Hello everyone, my name is Galang Putra Arvindo. On this occasion, I would like to present about our research utilizing the Global Positioning System GPS data from Sumatran GPS array SuGAr to measure seismic deformation related to the magnitude 7.6 Padang earthquake 2009. As a participant of International Conference on Radioscience, Equatorial Atmospheric Science and Environment Increase and the 6th Asia Research Note Year-End Symposium on Humanosphere Science. I work together with Nabila F. Shafitri, Sani N. Ayenwar, Muhammad Hamidi, Marzuki, Elistia El Namigo, DC Arisa as a research supervisor. An earthquake can impact the deformation of the ground affected by releasing energy. Deformation in an area can be observed before the earthquake or pre-seismic, during the earthquake or seismic, and after the earthquake or post-seismic. The deformation of the ground can be measured by change position of the GPS station installed around the epicenter and requires calculation using GMIT with the International GPS Station IGS and satellite orbit. The Sumatran GPS array SuGAr spans more than 1,000 kilometers of the convergent plate boundary between Indo-Australian and Eurasian tectonic plates. SuGAr provides a wealth of information on the Sunda megathrust and the Sumatran fault. The SuGAr has provided the possibility to measure of ground deformation. The focus of our research is the earthquake in Padang 2009. Sumatra, especially Padang, its tectonic biology is influenced by the subduction of the Indo-Australian Oceanic Plate and the movement of the Sumatran Fault. And this is the information obtained from the USGS catalog. The moment tensor diagram looks like that because the earthquake is combination of the strike slip and oblique slip. Method, we need to prepare data. The data we needed is earthquake information, Renex data SuGAr and AGS for 1 year, weather data model, atmosphere data model, and Z-type model. And tools we needed is software GMT and software Gamut Globkey. Flowchart. First, we need to get Renex data of IGS and SuGAr, atmosphere data model, weather data model, and Z data model. We can get it from website. Then we make work directory with command sh setup and controlling file in folder tables. Then we process gamut with command sh gamut. If error, we can recheck to program and files, and if no error, we get the file, H file, I file, L file, M file, N file, O file, T file, and summary file to in the next step. Then we edit file glob.cmd and glob.cmd. Then we processing Globkey with command shglwrite. We must define outlier data to process with Globkey. And the final result is some image file. Gamut output. Gamut output had form of numbers to be processed in the next step. And this is values of the post-fit normalized root mean square and WL fixed and NL fixed in percent. Both have very good value to process in the next step. Globkey output, this is some local deformation graph and position change of all SuGAR GPS station in 2009 generated from Gotki. The x-axis is the observation time and the y-axis is the shift direction of the receiver's location in the north direction and the east direction. Earthquake deformation mapping. This is a map to show direction of deformation. Deformation directions are not aligned from some location due to tectonic complexity. The dominant direction at the GPS station in Mentawai is towards the southwest, and in Sumatra it follows the Sumatran fault, northwest or southeast. On the graph, the value indicates the relationship between the distance of the station to the earthquake source, and the velocity of deformation has a negative correlation. From these results, we can conclude in the pre-seismic phase of the Padang earthquake 2009, there was no significant deformation. In the co-seismic phase, there was deformation of 2.62 to 47.13 mm to the southwest for the Mentawai vector zone. The Sumatra fault zone experienced 3.26 to the 25.13 mm deformation to the northwest, 20.20 mm to the southeast, 10.14 mm to the northeast, and 2.56 mm to the southeast. In the pre-seismic phase, there is a shift towards return to the original point of the deformation, and the distance of the earthquake source or epicenter and the value of deformation had a negative correlation. That's all for me. Thanks for your attention.